US Physics Olympiad year 2021. F equal MA, first round. As usual, it was given 75 minutes for 25 problems. If you want to get more interesting problems, just subscribe for this channel. The following information applies to problems 1 and 2. Problem number 1. At a time t equals 0, a small ball is released on the track shown with an initial rightward velocity. Assume the ball always rolls along the track without slipping. First problem. The ball starts at point A, turns around at point B, and returns to point A. Which of the following shows the speed of the ball as a function of time? Solution. The speed starts uniform, then uniform decreases to 0 as the ball reaches up the slope, and is instantaneously 0 when the ball is at point B. Then the ball speeds up again as it goes down the slope in negative direction, and returns to point A with the same speed it started with. So that's corresponding to graph A, and this is correct answer for problem number 1, and that was solution for problem number 1. Problem number 2. Which of the following shows the horizontal velocity of the ball as a function of time? Solution for problem number 2. The horizontal velocity is initially constant. As in the previous question, when the ball goes through the bend in the track, its speed is unchanged. However, the direction of its velocity quickly changes, so that only part of it is directed horizontally. Thus, the horizontal velocity very quickly drops. As the ball climbs up the hill till point B, its horizontal velocity decreases uniformly to 0, then very quickly increases in magnitude when it goes through the curve again. Therefore, the answer is E. And that was the solution for problem number 2. Problem number 3. Two massless rods are attached to frictionless pivots with their ends touching. The distances between the pivot points and the end points of the rods are shown below. Neglecting friction between the rods, if a force big F is applied at the left end of the left rod, what force F prime must be applied at the right end of the right rod to keep the system in equilibrium? Solution for problem number 3. Let's show the normal force between two rods. That's a small f acting on the right end of the left rod and on the left end of the right rod. To equalize equilibrium for the left rod, we must create force F small to apply this equation. For the left rod, we have equilibrium big F multiplied by r 2 meters equal small f multiplied by r 1 meter. For the right rod, we have F small multiplied by 0.5 meters equal F prime multiplied by r 2 meters. From here we have F small equal 2 big F and F prime equal 1/4 of small f, which is 1/2 of big F. And this is the answer B, and that was solution for problem number 3. Problem number 4. Alice and Bethany stand side by side on the Earth's equator. If Alice jumps directly upward in her frame of reference to a small height h, much less than the radius of the Earth, she will land a distance big D to the west of Bethany. If Alice had instead jumped to a height 2h, how far to the west of Bethany would she land? Neglect air resistance. Solution for problem number 4. Here we can find what is the total distance using formula distance d equal integral from 0 to 2 big T, where T is the time to jump from 0 to height h. V0 minus Vt, where V0 is initial tangential speed and the Vt is tangential speed on height h. So here we can use angular momentum conservation, because in case of a vertical jump we have angular momentum conservation. It means that V tangential multiplied by radius of Earth plus y, where y is current height, equals V0 multiplied by radius of Earth. Vy could be found from formula V initial vertical multiplied by time minus 1/2 gt square. And now Vt equal V0 r over r plus y. Here we can use that y over r is very small, so approximately we have Vt equal 1 minus y over big R. Initial Vi vertical we can find from formula Vi equal square root from 2gh, and the total time big T to jump from 0 to height h equal square root from 2h over g. Now we can put all this expression to our integral and find that distance big D equal this expression. Now after calculations we have that distance equal this expression, which is proportional to h power 3 over 2. It means that if we increase height twice, we have total distance equal 2 power 3 over 2d. This is answer E, and that was solution for problem number 4.